Hello everyone, myself Pawan DA. I'm from the Bhaskara section. Today I am here to discuss some of the basic topics about analysis and design of algorithms. Now let us dive into the subject. First of all, what is insertion sort? Insertion sort is a simple algorithm that works by iteratively inserting each element of an unsorted list into its corrected position in a sorted position portion of the list. It is a stable sorting algorithm, meaning that elements with equal values maintain the relative order in a sorted output. And here's the algorithm for the insertion sort. Input an array A of 0 to n minus 1 of n elements, and here is the output an array of A of 0 to n minus 1 sorted in increasing or non-decreasing order. Means if we give an unsorted number of digits to the insertion sort, it arranges in an increasing order or non-decreasing order. Here is the algorithm for it. For I equal to n to n minus 1, do a of I to v and I minus 1 to j, and while j is greater than or equal to 0 and a of j is greater than v, then do a of j plus 1 is equal to a of j, then j minus 1 equal to j, and v equal to a of j plus 1. Here are the steps to perform an insertion sort. Start with the first element as the sorted region. Take the next element from the unsorted region and compare it with elements in the sorted region. Insert the elements into the sorted region at the correct position. Repeat the process until the unsorted region is empty. The sorted region now contains an entire input list. Here is an example of insertion sort works. Suppose we have the following input list: 89, 45, 68, 90, 29, etc. And here is the first iteration. For I is equal to 1 to 6, V is equal to 45, and J is equal to 0. While 0 is greater than or equal to 0, and 89 is greater than 45, it is true. 89 is greater than 45 and 0 is greater than or equal to 0, and it is true. So E of j plus 1 is equal to A of j. Therefore A of 1 is equal to A of 0, and A of 1 is equal to 89, and j is equal to 0 minus 1 is equal to minus 1. J becomes minus 1. Then while minus 1 is greater than or equal to 0, no, minus 1 is less than false. So A of 0 is equal to 45. And here comes an array in a sorted way. Like 45 comes before 89, and the rest of the listed elements remains the same. Now let's go to the second iteration. For I is equal to 2 to 6, V is equal to 68, J is equal to 1. While 1 is greater than or equal to 0 and 89 is greater than 68, the statement is true. So A of j plus 1 is equal to j. So A of 1, while 1 becomes 2, so A of 2 is equal to A of 0, and A of 2 is equal to 89. J is equal to 1 minus 1, which becomes 0. And while 0 is greater than or equal to 0 and 45 is greater than 68, no, the statement is false. 48 is not greater than 68. So A of 1 is equal to 68. Now here is the array 45, 68, 89, and the rest remains the same. Now let's go to the third iteration. For I is equal to 3 to 6, V is equal to 90, J is equal to 2, and while 2 is greater than or equal to 0 and 89 is greater than 90, it is false because 89 is not greater than 90. So A of 3 remains the same as 90. Now here is the array, and this is the fourth iteration, and this is the fifth iteration. As you can see here, you can see the sorting of digits in the fourth iteration. For I is equal to 4 to 6, V is equal to 29, J is equal to 3, and the first statement is true. So A of J becomes 90 and J becomes 2. Now in second iteration, second statement is also second while statement is also true. So A of J becomes 89 and J becomes 1. Third statement is also true. So A of J becomes 68 and J becomes 0. And fourth statement also true. That's why A of J is equal to 45 and J is equal to 0. And but last statement is false in the fourth iteration. So A of 0 remains 29 and here is the sorted array. And in the fifth iteration, as you see, the first while condition is true, so a of j becomes 90 and j becomes 3. Second while statement is also true, so a of j becomes 89 and j becomes 2. Third statement is also true and fifth statement is also true, but the last while condition is false, so a of 1 remains 34. And there you can see the sorted array. Now this is the last iteration, the sixth iteration. So the first while condition is true, so a of j becomes 90 and j value becomes 4. And the second while condition is also true, so a of j becomes 89 and j value becomes 3. Third while condition, it is also true, so a of j is equal to becomes 69 and j becomes true. And last while condition also true, that's why a of 3 becomes 45 and j value is 1. And as you can see, here is the increasing order of the array, and this is a sorted array where first we give an unsorted list. Now this algorithm gives an sorted array. Now the sorted array is 17, 29, 34, 45, 68, 89, 90, which is in the increasing order or a non-decreasing order. Insertion sort efficiency. Uh, how insertion sort is efficient? Insertion sort is a simple sorting algorithm that can be finally sorted array one item at a time. It sorts the array one item at a time. Its efficiency is based on its ability to efficiently sort small arrays or partially sorted arrays. Insertion sort has a time complexity of 0 bracket of n to the power 2 in the worst case scenario. The best case scenario on a insertion sort. The worst case time complexity for insertion sort is O of n when the array is already sorted. In this scenario, the algorithm only compares each element with its adjacent element and moves on to the next element. This makes insertion sort highly efficient when dealing with nearly sorted arrays. Summary. Insertion sort is a simple and efficient algorithm for small data sets or partially arranged arrays. While it may not be most efficient for large data sets, it has its advantages in specific scenarios. Understanding the efficiency and the limitations of the insertion sort can help in choosing the right sorting algorithm for different tasks. Now let us move to the introduction of topological sorting. In this method, we use it to order the verticals of directed acyclic graph DAG in a linear order. It ensures that for every directed edge from vertex U to vertex V, U comes before V in ordering. This ordering is useful in scheduling tasks, resolving dependencies, and optimizing operations. Understanding DAG graphs. A directed acyclic graph is a graph with directed edges and no cycles. In DAG, nodes are arranged in a way that there is a consistent direction of dependencies between the nodes. Topological sorting is only applicable to DAGs as it requires a linear ordering of nodes without any cycles. Here is a diagram of directed and acyclic graph. Depth first search algorithm overview. DFS is a recursive algorithm that explores as far as possible along each branch before backtracking. It uses a stack to keep the track of nodes to visit and marks each visited node to avoid revisiting them. DFS is commonly used in the graph traversal, topological sorting, and finding connected components in a graph. Here is a diagram of the DFS. This is a topological sort. Thank you. If you do like the video, please like, share, and subscribe.